Hi, and welcome to the calculating current example. Our job in this problem is to calculate the average current during the entire time interval that's shown in the following figure. You can see that the time is the horizontal axis and current is the vertical axis, but our job is to calculate the average amount of current that's flowing. Now, in order to do that, we're going to need to turn our attention to the four different regions of current. You can see the first region of current is 2 amps, the second region of current is -1 amps, the third region of current is 1 amp, and the fourth region, which is pretty short, still though the fourth region is -1/2 amp. Our job then is to calculate the total amount of charge, and once we find the total amount of charge, then we can find the average current by dividing that by the amount of time. So to find the total amount of charge, we're going to have to find the charge from each of the four regions. So I can calculate, for example, Q1. Q1 is going to be the current that flows during that time, 2 amps, multiplied by the time interval over which that occurs. Now you can see here that this time interval here is 1, 2, 3, 4, 5 seconds. And so this is going to be multiplied by 5 seconds. And this means that a total of 10 coulombs flows over that first interval. Now the second interval, Q2, is going to be a negative current, -1 amp. That just means that the current is flowing in the opposite direction, multiplied by, you can see the time interval here is 3 seconds. So we're going to have 3 seconds, and that's going to end up being -3 coulombs. Q3, this is going to be +1 amp. I'll just leave it as 1 amp, and the interval here is going to be 1, 2, 3, 4, 5, 6, 7 seconds. And so that's going to be multiplied by 7 seconds, and therefore the total charge that flows will be 7 coulombs. And then the fourth region, Q4, Q4 is going to be equal to -1/2 amp multiplied by the time, and that time is going to be 1, 2, 3, 4 seconds. And therefore this is equal to 2 coulombs. Now the total amount of current, which I can represent as delta Q is going to be equal to the sum of the four currents that we just calculated. So this is Q1 plus Q2 plus Q3 plus Q4. And therefore this is 10 plus -3 plus 7, oops, forgot a negative sign right here, plus -2 coulombs. This works out to be 12 coulombs. And of course, then the question is how much time passed. Well, there we can just say that delta T is going to be T1 plus T2 plus T3 plus T4, which is 5 seconds plus 3 seconds plus 7 seconds plus 4 seconds, which works out to be a total of 19 seconds. And the math is not going to work out nice and even here, but it rarely does in the real world. So the total current, the average current that flows throughout this period of time, is going to be delta Q divided by delta T, which is 12 coulombs divided by 19 seconds, which turns out to be 0.632 amps, or as an electrical and computer engineer would probably prefer to write it, 632 milliamps. So by taking each of the four regions one at a time, we were able to calculate the amount of charge that flowed during that time. We were able to find the length of the time, and then ultimately we were able to calculate the average current. Thanks for your attention.